Now, confirmed reports show that the U.S. Navy is hardening its Puget Sound shipyard to prepare for a major earthquake, and it's right next to the Cascadia subduction zone.
Puget Sound. The seemingly tranquil waters in the Northwest Pacific is being urgently reinforced, because right beneath it, the Cascadia subduction zone is silently accumulating energy. That's a fracture nearly 1,000 kilometers long, where two of Earth's tectonic plates, Juan de Fuca and North American, are grinding against each other, preparing for a jolt that could rip apart the entire region.
In Cascadia, you have one plate diving down beneath another. This section gets locked, and it pushes this part up. When the fault ruptures, when the amount of stress overcomes the friction, it bounces back, which lifts up the water above it and causes that water to flow out in all directions. And that water flowing out in all directions is the tsunami.
This mechanism once wiped out the entire coast of Japan in 1700. And now, similar fractures are appearing simultaneously across the planet. Can humanity survive another planetary reshaping?
These really dramatic events have happened in our past, and they will happen again.
The signs of doom are becoming increasingly clear. In March 2025, residents in northern Myanmar witnessed an unprecedented sight. The ground before them split in two. A massive crack over 15 kilometers long ran through fields and villages, swallowing roads, canals, and homes. CCTV footage capturing that moment spread worldwide, and seismologists called it the deepest surface fracture ever observed in Southeast Asia. This M7.7 earthquake not only destroyed, but also opened a new boundary between two geological plates previously considered stable. At the same time, on the other side of the Pacific, the research team at Lamont Doherty Earth Observatory in the U.S. announced a discovery that stunned the scientific community. Microplates, subtectonic plates, in the Cascadia subduction zone are beginning to separate. This isn't a typical faulting phenomenon, but the first sign of a larger process rift propagation, the spreading of cracks through the planet's crust. What's happening in Cascadia, once dubbed the sleeping geological bomb, could be the starting point for a new tectonic cycle where the entire Earth's crust begins to shift back into position. And while the ground cracks, the planet's magnetic sky is also beginning to fluctuate, according to NOAA. From 2023 to 2025, the speed of magnetic pole drift, the point where compass needles point, has tripled. It seems the Earth's core is in turmoil, causing the planet's magnetic field to destabilize, weaken in some areas, and reverse poles faster than ever. Some geophysicists call this the sign of the planet's heart losing its rhythm. When piecing these events together, a terrifying pattern emerges. The Earth is no longer stable. The planet's crust is shifting, separating, and restructuring at a global scale. The question is, how long has it been starting? What is unfolding today is not a new phenomenon. Earth's history has recorded multiple global crustal shifts events powerful enough to relocate the poles, melt ice across half the planet, and freeze the rest in just a few centuries. The earliest evidence comes from 1513, when the Piri Reis map was discovered in Istanbul. This goatskin parchment, drawn with natural ink from the Ottoman Empire era, depicts the Antarctic coast without ice, with mountain ranges, bays, and contours that match modern radar data in an uncanny way. Analysis of the map suggests the cartographer drew from even older sources, possibly predating the last ice age. If true, that means Antarctica once lay in a temperate zone before shifting to its current polar position. 4 centuries later, in 1958, geophysicist Charles Hapgood published his work The Earth's Shifting Crust, in which he proposed the concept of Earth crust displacement, the wholesale sliding of the Earth's crust. According to him, the crust could slip over the viscous mantle beneath, shifting thousands of kilometers simultaneously, altering the geographic poles in just a few thousand years. Hapgood lacked satellite data, or GPS, like we have today, but observations of sediments, glacial directions, and fossil distributions from that time all pointed to rapid climate zone changes that couldn't be explained by orbital variations alone. Albert Einstein, who read the first draft, wrote the foreword for the book, calling the hypothesis worthy of serious consideration if more physical evidence emerges. Most recently, in 2014, studies published in PNAS bolstered that hypothesis. The team of geologists called it the Younger Dryas Impact Hypothesis, a large-scale celestial or tectonic event around 12,800 years ago, coinciding with the Earth's abrupt entry into a short ice age. Sediment data containing iridium, platinum, and global burn markers indicate a high-energy incident that disrupted the planet's magnetic field, altered ocean currents, and triggered a worldwide climate collapse. In the same period, many megafauna species went extinct, and early cultures vanished from the archaeological record. These puzzle pieces form a unified picture. The Earth has slipped its crust at least twice in the last 100,000 years. Each time, it brought magnetic pole redistribution, continental shifts, and global biological crises. That means humanity is facing a terrifying reset it has never witnessed. Can we survive it? Let's look back at history, when civilizations confronted the Earth's reshaping. In truth, many civilizations have been erased from the map, scattered across ocean floors, from the North Atlantic to Southeast Asia. Three of the most prominent areas, Atlantis, Doggerland, and Sundaland, once existed, once had inhabitants, and once vanished in timeframes aligning with global upheavals at the end of the last ice age. First, about Atlantis. The name Atlantis may evoke mythology, but the location described in Plato's ancient texts aligns with regions showing extreme geological shifts, the area between Gibraltar, the Azores, and Madeira. Ancient records say this continent disappeared in a single day and night, a description that matches unusually well with the scale of tectonic collapses and transatlantic tsunamis confirmed by modern geological models. At the Azores, satellite imagery and bathymetric surveys seafloor topography reveal simultaneous subsidence structures, possibly due to subduction zone collapse. Some researchers, like Dr. R. Blaschke in 2024, call this geophysical evidence that may fit Plato's description better than any other location. The next continent swallowed by the North Sea is Doggerland. This landmass lay between modern-day Britain and Denmark. Archaeologists say it once held forests, rivers, and traces of human settlement. Sonar surveys and sediment core drilling by the British Geological Survey and the Europe's Lost Frontiers project have uncovered abrupt layers of mud, sand, and peat at depths of 20 to 40 meters. The sediment structure indicates flooding occurred rapidly, possibly in just a few decades. Pollen samples and ancient DNA in these cores show Doggerland was once temperate grassland, then submerged by rising seas and submarine landslides, consequences of a geological event known as the Storegga Slide, around 200 years ago. This wasn't an isolated incident. The slide triggered tsunamis over 20 meters high, sweeping across Europe's entire coastline. Doggerland vanished, taking with it an entire prehistoric population, a nascent civilization erased in a single generation. On the other side of the planet, similar evidence emerges in Southeast Asia, beneath the seas of Java, Borneo, and the Malay Peninsula today once lay an ancient continent, Sundaland. Sediment data and geomagnetic maps published by Solihuddin et al. In Nature 2023 show sea levels in this region rose over 120 meters in just 10,000 years. Sonar surveys off Borneo and southern Vietnam's coast have detected networks of ancient rivers, submerged channels, and dry alluvial shelves, proving this was once a vast landmass habitable by humans. Carbon isotope analysis in sediment cores shows Sundaland's collapse coincided with the end of the Younger Dryas 11th 600 years ago, the same time global climate reversed and polar ice melted rapidly. If true, Sundaland was a prehistoric civilization wiped from the map in the same geological cycle that once pushed Earth's poles from their original positions. Atlantis, Doggerland, Sundaland. Three lands submerged in the same time frame, all bearing signs of crustal shifts or sudden tectonic events. Each time, the planet lost land masses, suffered mass extinctions, and saw entire ancient human cultures erased from historical memory. If these cycles are natural laws, and if current data shows a similar process igniting, then modern civilization cannot escape that rule. As tectonic plates continue to separate, as magnetic poles drift faster, and as polar ice disintegrates, we stand before a familiar scenario, another planetary reset, where entire urban systems, industries, and civilizations will be submerged in just a few centuries. And what about us? We can only stand helplessly, awaiting the most terrifying things on the horizon. The data shows the catastrophe is drawing ever closer. Early in 2025, a publication in Proceedings of the National Academy of Sciences (PNAS) highlighted a disturbing correlation: magnetic pole fluctuations coinciding with a global increase in earthquakes. The report used data from over 40,000 earthquakes in the past 2 decades and found that when Earth's magnetic field weakens, average seismic activity rises 18–22%, especially at tectonic plate edges. This suggests magnetic variations are not just electromagnetic phenomena, but reflect mechanical energy shifting in the core and mantle. But the strongest evidence comes from deep seismology, analysis of low-intensity seismic waves. Collected from global sensor networks from 2023 to 2024 show the inner core, a solid iron-nickel sphere, 400 kilometers in diameter, is rotating opposite to the outer core. This phenomenon has never been recorded so clearly before, when the 2 core layers spin counter to each other. Friction and molten metal convection are disrupted, leading to magnetic field changes and abnormal energy transfer to the overlying mantle. Professor Yi Yang from Peking University puts it succinctly. The Earth is like a machine with 2 gears, and right now, those 2 gears are running in opposite directions. If this continues, mantle flow patterns will have to reorganize, triggering intensified volcanic activity, earthquakes, and crustal shifts. Subduction zones may halt while new rifts open, similar to the tectonic restructuring over 12,000 years ago, at the end of the last ice age. The terror lies not in the speed, but in the synchronicity. The inner core reverses direction. The magnetic field destabilizes. Polar ice melts rapidly, and surface cracks are expanding along the exact stress axes predicted by mantle simulations. All these changes are happening at once, all pointing to a common origin: energy from the core shifting phase. Many geophysicists call Earth's core the heartbeat of the planet. When it changes rhythm, the entire crust and climate oscillate in response. For over half a century, Charles Hapgood's Earth crust displacement hypothesis was seen as a scientific misstep. He argued that Earth's crust once slid en masse over the mantle, relocating poles and causing global cataclysms. But in 1958, Hapgood lacked physical models, deep seismic data, and carbon-14 dating errors undermined many of his points. Geophysicists argued it was impossible for a crust tens of kilometers thick to move without shattering the planet. For decades, Hapgood's name was synonymous with pseudoscience, but what's unfolding since 2020 is forcing the scientific world to reconsider. Data from seismic stations, gravity satellites, and 3D mantle simulations are reconstructing a very different and more terrifying picture. In 2025, the Lamont Doherty Earth Observatory team published the most detailed 3D seismic map of the Cascadia subduction zone. Results show the plate system there is no longer operating as a unified block, but fragmenting into small microplates, a phenomenon geologists call plate segmentation. This is no longer local fluctuation. The plates are truly losing mechanical cohesion, sliding independently over hundreds of kilometers. Seismologist John Vidal, USGS, in the press conference announcing the data, said one short but weighty sentence. We're seeing rifts where there shouldn't be rifts. For many, that's the scientific way of saying what Hapgood once envisioned is beginning to happen. Around the same time, studies in Nature Geoscience and PNAS show mantle flow is changing direction, a phenomenon called mantle flow reorganization. Deep convection maps reveal many Pacific subduction zones slowing or pausing, while others, especially the East African Rift and Southwestern Americas, record unusually strong mantle upwelling. When one part of the planet stops swallowing crust, while another pushes hot material up more forcefully, global stress becomes unbalanced. That's exactly what Hapgood described in the crude language of the last century sliding crust zones, crustal areas slipping due to internal mantle forces. When modern science simulates this on supercomputers, the stress lines and crustal movement vectors in Lamont Doherty's 2025 models match uncannily with descriptions in his manuscript Path of the Pole from over 60 years ago. At scientific conferences, the divide is clear. One faction argues these fluctuations are just normal expressions of active plate tectonics, the planet's self-regulating system. The other, though not yet daring to affirm publicly, is starting to ask why are all phenomena, from pole drift, mantle flow, ice melt to deep earthquakes, happening simultaneously. Charts from NOAA and NASA GRACE show clear parallel curves between magnetic pole drift speed, polar ice mass loss, and mid-depth earthquake frequency from 70 to 300 kilometers, right in the zone where mantle activity is strongest. That correlation cannot be dismissed lightly. A researcher at Caltech stated at the 2024 AGU conference, "The hardest thing for the scientific community to accept isn't the lack of data, but that the data is leading us back to theories once buried. That statement reflects the mood of the entire geological community. They may not want to believe Hapgood, but the numbers don't allow complete denial. After all, modern geophysical models are proving one thing when the crust destabilizes globally. All geological processes, from magnetic fields, earthquakes to ice melt, react in a chain, and when that happens, the boundary between hypothesis and reality becomes fragile. Major scientific journals, from PNAS to Nature Geoscience, are starting to reuse once-discarded language crustal instability, mantle decoupling, global stress redistribution. Researchers aren't yet calling it crustal displacement outright, but in essence, they're describing the same phenomenon. Modern science may reject Hapgood theoretically, but it's proving him with facts. In science, no hypothesis dies forever, only those lacking evidence. And today, that evidence is returning. When real-world data starts matching what a ridiculed theory once predicted, the question is no longer whether Hapgood was wrong, but whether he was right too soon. If current observations are just the beginning of a crustal shift cycle, then what humanity is witnessing may not be a short-term anomaly, but the opening signal of a global restructuring, the third in the planet's history. The data from 2023 to 2025 is forming a clear pattern. The Earth is entering a new global tectonic cycle, phenomena that seem disjointed: the Myanmar earthquake, microplate separation in Cascadia, rapid magnetic pole drift, and Antarctic ice disintegration are all occurring simultaneously, precisely recreating the sequence of events that led to planetary-scale geological changes over 12,000 years ago. Paleoclimate scientists point out that the average interval between major Earth reversals is 11,600 to 12,000 years, a figure that aligns with the present. In each such cycle, the planet passes through an energy reset phase, when the crust, magnetic field, and mantle flow all transition to new structures. New data from GRACE and Sentinel-1 shows crustal stress levels rising sharply at tectonic plate intersections, especially in East Africa, Cascadia, and Antarctica. In geological history, this is the precursor sign of a crustal shift. Notably, ancient civilizations all preserved memories of a similar era. Symbols of water gods. Ice gods appear from Egypt, Sumer to the Andes, like warnings of an event that once reshaped the planet. Those stories may not be mythological, but humanity's genetic memory of a previous destructive cycle. If all the evidence holds true, then the third Earth reset cycle has begun. The Earth isn't ending, it's regenerating itself. The remaining question is, can humanity survive this regeneration?